Okay, this is a past paper question from the Limpopo Provincial Grade 10 November 2018 question paper. And it's an equations of motion question for mechanics. It says two athletes, X and Y, compete in a 100-meter event. X accelerates uniformly at 2 meters per second from his starting blocks. So if he's going from his starting blocks, his initial velocity is going to be 0 for 4 seconds to reach his maximum speed. And then it says to you, calculate the maximum speed that X reaches. So the first half of this question is fairly straightforward. We're going to say, okay, 4.1.1, Vf equals Vi plus A delta T. We want to know his maximum speed, which we're going to be calling his Vf, or final velocity. So Vf is going to be his initial velocity. He started from the starting blocks, which is 0, plus the acceleration, which is 2, times the amount of time that he runs for. So his final velocity is going to be 8 meters per second, obviously in the direction that he's running. Then it says to you, what is the distance that he runs in 4 seconds? So remember now that this is what we call delta x in an equation, his displacement, and you can't use speed equals distance over time once you've got acceleration, so you have to use an equation of motion. So the most appropriate one, or the easiest one, is delta x equals Vi delta t plus a half A delta t squared. So if we substitute in here, we've got my initial velocity is 0 plus a half of my acceleration, which is 2. Obviously, I substituted 0 there because it was all 0 times anything is 0. So a half of 2 times 4 squared. My displacement over here is going to be 16 meters in the direction that he's running. Then it says that X maintains his maximum speed for the rest of the race. So X's maximum is going to be 8 meters per second. Okay. Now they tell you, calculate the time taken for X to complete the entire 100-meter race. So let's have a think about what's going on here. What did X do? If we draw this on a graph here, okay, if we have a velocity versus time graph, X started from rest at time equals 0, his velocity was 0, and then he accelerated to a maximum velocity of 8. It took him 4 seconds to get here. So if this is 4, we will accelerate steeply for 4 seconds, and then we will reach our maximum velocity of 8 meters per second for the rest of the race. Okay, and he must then complete the entire race. So this is what his velocity time graph looks like. He starts from rest, he accelerates, and he keeps going. If we look at him then differently about what's going on the race, and we assume that this is his displacement, here is 0 and here is 100 meters. Okay, we know that in 4 seconds he has gone 16 meters over. Okay, so here he has gone 16 meters of his 100 meters, and it took him 4 seconds. They are now asking, calculate the time taken for X to complete the entire 100-meter race. So he went 16 meters in 4 seconds. So how much has he got left to run? He's got all the way from 16 to 100. So how far has he got to complete the race? He's got 100 minus 16 meters, because he's already gone 16 meters. So this is 84 meters. He's got 84 meters left to run the race, and he is going to run this at a speed of 8 meters per second, because the question says he maintains his maximum speed for the rest of the race. So if we want to find out how long it's going to take him, we know he's going to run 84 meters, because at the end of 4 seconds, that's where he is. We now need to go and say, okay, how long is it going to take him? We need to use an equation of motion, and we can handily use this other one again over here. the same one that we used a moment ago, delta x equals vi delta t plus a half a delta t squared. Okay, so we know that he needs to run the 84 meters because he's already run 16. His initial velocity is the same as his final velocity because he stays at his maximum speed, which means he actually is not accelerating. His acceleration is 0 at this point. So it's 8 times the time plus a half times 0 times the time squared. Okay, so this term is going to go to 0. So we get 84 equals 8 delta t plus 0, which means that if you solve this now, what is the delta t? The delta t is 10.5 seconds. But you've not completely answered the question because remember, this 10.5 seconds is over here. It's for the 84 meters. So the total time, okay, is going to be the 10.5 seconds plus the 4 seconds where he was accelerating, which is 14.5 seconds. Okay, so this one is fairly straightforward, but now it gets more interesting because we are going to have a friend join us, and the friend is Mr. Y, Mrs. Y. It says Y has a bad start and leaves her starting blocks nearly a half a second after X. When X reaches his maximum speed. Okay, so let's draw Y's track underneath X's track. They've both got to run this 100 meters, okay? But we want to look at this information. It says when X reaches his maximum speed. Now, here, remember, he reached his maximum speed over here, okay, at this space on the racetrack. He was at 16 meters, but it took him 4 seconds, okay? So when X reaches his maximum speed, Y is 6 meters behind X. So this is X and this is Y. And at 4 seconds, when he got to his maximum speed, X was at 16 meters. So 6 meters backwards from this, okay, is going to be, if that is 16, and we go 6 meters backwards, over here will be 10 meters, okay? So it says she had a bad start. She left her starting blocks late, but when X at 4 seconds had traveled 16 meters, remember we know this from 4.1.2, okay? He was at 16 meters. So when X is at 16 meters, Y is 6 meters behind, okay? But Y has now reached her maximum speed of 9 meters per second. And now for the rest of the race, X and Y maintain their maximum speeds. So she's going to run all the way from 10 meters to 100 meters at her maximum speed of 9 meters per second. So if we looked on the graph, she will have started a little bit later, okay? And she will reach her maximum speed. She is accelerating faster because she's catching up, and then she has got a maximum speed of 9, okay? So this is Y and this is X. So she accelerates more even though she started late, but she has a higher maximum speed. So that is what their two graphs would look like. Now it says to you, use appropriate calculations to determine who, X or Y, wins the race, i.e. who reaches the finish line first. So if you want to do this, okay, you can't think of the whole race because we don't actually have exact information for Y, okay? We only have the information for Y. The exact things we know about her are at this point over here. She's 10 meters behind X, which leaves her with 90 meters to run over here. So Y has got 90 meters to run, but she is running this at 9 meters per second. At this same moment in time, our friend X is over here, and they only had 84 meters to run, but they were running at 8 meters per second, and we worked out it took them 10.5 seconds. So the question is, if Miss Y is running at 9 meters per second. Can she run this last part of the race faster than X? So it says, use appropriate calculations to determine X or Y wins the race. Who reaches the finish line first? So if you have a look here, we know a VI for Y, and we know the VI equals the VF because she's at constant velocity, so the A equals 0. We are looking for a delta T, and we've worked out from the information in the question that her delta X is going to be 90 meters. She needs to run 90 meters to get to the finish line because she's 10 meters from the start when she reaches her maximum speed according to the question. So we can still use this exact same equation of motion that we've been using. Delta X equals VI delta T plus a half A delta T squared. Now remember, she's not accelerating. So this term is going to go to 0 because anything multiplied by 0 is 0. My delta X is 90. My VI is 9. And we are looking for the delta T. So here we go. Delta T is going to be equal to 10 seconds. So in 10 seconds, Y will have reached the finish line. But at that same moment in time, X was taking 10.5 seconds. So Y will finish a half a second before X, and Y wins the race. So you have to check you've answered the question. It says to say, determine who wins the race. So you have to state it, who wins the race. Y is winning the race because they got to the finish line a half a second before X. So the trick here is to understand where the two people are relative to each other at the same time for the information that you are given.